Alright, so this is the key for our last product quotient chain rule assessment. So what you're going to see is, I don't know, 4, 10, like 12 problems. Product quotient chain rule, and then just some other trig derivative formulas. So here we go. First one, y is equal to 4x squared plus 1 divided by tangent x. Y prime equals, so low, tan x d high, the derivative of the high is 8x, minus high, derivative of the low, all over low squared. Okay, that's fine. I'm not going to worry about simplifying it right now, but just so you see how the rule is applied. Next problem. Y equals e to the 4x squared plus 1x times sine x. Okay, I definitely need product rule at some point in time because of this. And I'm going to need the chain rule to get the derivative of this thing in blue. I'll start product rule though. Product rule says leave the first one alone. And then multiply by the derivative of the second one. And then leave the second one alone. Multiply by the derivative of the first one. So I'm almost done, except for the fact that I don't really want to leave this in my answer. Like if I stopped there, I'd still be, I'd still have a derivative needing to be found in my answer. So we'll take this down one more line. Realize the only other work I need to put into this problem is actually finding the derivative of that piece in purple. So I'll do some work real quick. We'll come over here. So the inner, that's 4x squared plus x. The derivative of the inner is 8x plus 1. The outer, that's e to the x. Its derivative is e to the x. So the derivative of the outer evaluated at the inner. So e to the 4x squared plus x multiplied by the derivative of the inner. So what you see in purple up there is going to get replaced with this in my final answer. So y prime is this stuff. Except we'll replace what's in purple. So we'll have e to the 4x squared plus x times 8x plus 1. Here we go. So there's my final answer. I'll put it in yellow. So I needed the product rule and the chain rule in that problem. Could that be simplified? Yeah, it could. Not that worried about it for now. This is just, we're looking at the rules for derivatives. Okay, the next problem, 3. This is a fun one. Y equals square root e to the 3x, then plus 9. I'm going to rewrite the given there. Like this. That way, I would rather deal with that quantity to the 1/2, so I can see that power rule. That's when the 1/2 is going to come out front. Anyhow, so that's chain rule. I've got an inner and an outer. The inner is e to the 3x plus 9. The outer is x to the 1/2. The derivative of x to the 1/2 is 1/2 x to the negative 1/2. The derivative of the inner, let's see, well, there's two functions there. So, okay, the outer is e to the x. The inner is 3x. So I'm kind of making a new problem. I got to a point where I said, I need to find the derivative of that thing in green. Oh, to do that, I need, I left something off. The outer is e to the x plus 9. Anyhow, though, I got to the inner, that thing in green, and I said, I need its derivative. As I looked at it, I said, well, I'm going to need chain rule just on that alone to find its derivative. So that's kind of the secondary work I'm doing. So the derivative of that outer is e to the x. The derivative of that inner is 3. So the derivative of the outer evaluated at the inner. So 3x will get plugged into e to the x. So e to the 3x times the derivative of the inner, which is 3. So this stuff right here, it's going to get connected. That's the derivative of that inner function, e to the 3x times 3. Okay, so I got a few pieces I'm working with, 4 actually. I've got the green, I've got the blue, I've got the purple, and I've got the orange. So we go, okay, it's the derivative of the outer, it's this one, evaluated at the inner. So 1/2 evaluated at the inner, that's e to the 3x plus 9, multiplied by the derivative of the inner. That's the purple stuff. It's right here. So e to the 3x times 3. Alright, in case you missed the announcement, there's no line to buy homecoming tickets right now. Alright, so there's our y prime. Yep, you could simplify it. I'm not that concerned right now. That was a tough problem, though. You had to use the chain rule actually twice. So, good job. I'll put our answer in yellow. Alright, next problem on the assessment. 4 is y equals x to the 3/2 plus 1 squared times x minus 9 to the 15th. We're going to need product rule. Okay, I see this function in blue, and I see this function in green. So if I could just find each of their derivatives, life would be good. Life would be easy. So let's take this one in green. I'm going to need its derivative. The outer is x to the 15th. The inner is x minus 9. The derivative of x to the 15th is 15x to the 14th. The derivative of x minus 9 is just 1. Okay, so what it goes, derivative of the outer evaluated at the inner multiplied by the derivative of the inner. Okay, so that is the green thing's derivative. Now come over to blue. That's got an inner function and an outer. The inner is x to the 3/2 plus 1. The outer is x squared. The derivative of x squared, that's 2x. The derivative of x to the 3 halves plus 1 is 3 halves x to the 1 half. Move the exponent out front and take 1 away. Okay, so the derivative of that piece in blue, the derivative of the outer, evaluated at the inner, multiplied by the derivative of the inner. Okay, so the blue thing's derivative we'll put in blue. The green thing's, the green function's derivative we'll put in green. So my answer is going to be really, it's going to take all 4 of those elements, the 2 blue ones and the 2 green ones. So I'm gonna need a little more room. Okay, all this stuff. New page. Okay, so I'm gonna go x to the 3 halves plus 1 squared times 15 x minus 9 to the 14th plus the second function left alone, x minus 9 to the 15th times the derivative of the blue one, which was 2 x to the 3 halves plus 1 times 3 halves x to the 1 half. Not that worried about simplifying it right now, so we'll just stop there. So there you go. There is y prime for number 4. Alright, so that is one page of the assessment.